should be called that. Go ahead.
So just the difference in points between the lowest and the highest on both of them.
It is called something statistically. It's not called a point spread, unfortunately, because in sports it's always called that, right?
No.
Unfortunately, we have to think of a new name because we're statisticians. That's called the range. And that is a measure. That is a measure. I'm going to put it over here. The range of the data. And you can think of it as the high minus the low. And that's exactly what it is. It's the highest minus the lowest, whatever that distance is. It gives you a distance between the extremes of the data. So for Bert, or for Ernie I should say, we'll do his because he's less rangy. Ernie he's 4, yeah, 83 minus 79, right? Which is 4 points of range. 4 points of range. How about Bert?
39.
39! Because he has that 100, right? But he also has that, right, which gives you 39 points of range. I love this. I love this because it gives us a way to quantifiably discuss the differences in Bert and Ernie. I love it because of that. We can say, oh, this is fantastic. We now know that Bert's range is what? Roughly what? Compared to Ernie's?
10 times.
It's about 10 times, isn't it? 39. Call it 40. Just, round it up. Ish. It's about 40. It's about 10 times as variant as Ernie's range. Love it. What's the problem with looking only at range? Rory, go!
Take points off of them, like across the board, and you can still have the same range.
Oh, good. Very good. So if, for example, all those scores were dropped by 10 points, they'd have the exact same range, wouldn't they? But what would change? Their average would change. So suppose, for example, Ernie's scores dropped by 20 points. Yeah, 20 points. His average is now a 61. Hopefully you guys buy that, right? If everything dropped by 20 points. If you don't buy it, that's okay. There's a couple homework questions that get into that for you as far as why that is. So that would be 61, but his range would still be 4, so you'd say, he's consistent. And then somebody would say, well, he's consistently crappy. But consistent, for sure. So I think I love what you said, Rory, because the problem with range, and this is why nobody uses it, unfortunately, statistically, I should say, people use it all the time, not statistically, is it ignores the average that's underlying. Here's the deal. I mentioned before, we want to talk about measures of variation. What we really want to measure is variation around an average. We want to measure the variation around an average. So we want to really talk about these double arrows right here, and I really want to keep them together. I want to be able to talk about consistency versus inconsistency, but never lose sight of where this stuff is. This is not unimportant. It can be inconclusive, but it's not unimportant. So I want to kind of keep this while leading towards this. And although I love range and it's so intuitive, it's so very intuitive, it's not used because of that. If you go back to the raw data, Bert and Ernie, suppose Bert's scores were 61, 61, 61, 100, and 100. Okay, what's the same? It's still 39, isn't it? It's still 39. Would you have a different view about his consistency or inconsistency then? Maybe. I heard some no's. Yeah? Maybe no, maybe yes. Suppose it was 61, 100, 100. What did he cheat? Careful. Suppose it was 61, 100, 100, 100, 100. Would you have a different view about that versus this? I'm thinking, yeah. Then the bad day hypothesis starts to creep in, maybe. The 61, 61, 61, 100, 100, it gets a little bit trickier to get the bad day hypothesis. And again, based on a sample size of 5, you're like, well, there's 60% bad days and 40% good days. Maybe, but the variance is too wide to even chit-chat about that. So any ideas of how we confuse these data points with the centers that are under here? Karen, what's on your mind?
Like maybe just the range from the average score, like how much above or below the 81% they are.
I predicted you'll come up with that. I predicted you'll come up with that. somebody, not you, Carolyn, somebody in the room of 35, the chance of none of you coming up with it is essentially 0, to the chance of somebody is close to 100%. You'll learn that in this class too. See, it's a principle of redundancy. Redundant. How many of you guys put a battery in your alarm clock? How many of you still use alarm clocks? Let's go back to that. About 3 of us. 3 of us. You put batteries in them, 9-volt batteries? Why do you put 9-volt batteries in your alarm clocks? In case the power goes out. In case the power goes out, you still keep the time going. How many of you are using a TI-83 graphing calculator in this room right now? Yes, it's got a backup battery called a lithium battery in the back. That way if you pull the 4 AAA batteries, if you have stuff saved, you don't lose what's saved. Why? Because the chance of all of that crap going dead at the same time is essentially 0. I mean, you've heard of the principle of redundancy. In your second project, you'll analyze COCC and its network. There are 6. Your My Documents folder is backed up onto 6 redundant hard drives. So when you save something in your My Documents folder, it's actually saved in 6 places, 6 copies. Why is it saved in 6 places?
Because they're probably not all 6 going to go out at once.
Because the chance of all 6 going out at the same time is essentially 0. The chance of one of them going out is actually pretty good, believe it or not. Out of 6, the chance of one of them going bad is actually pretty good. The chance of all 6 of them going out, which is the only time something catastrophic would happen. You could lose 5 of them, as long as the last one holds. And the chance of them all failing is essentially 0. You'll calculate that in your second project. That's why I jokingly mentioned that when I said the chance of somebody coming up with this. It's almost a given, especially if I ask the right questions. So, Carolyn, actually, you know what? We're getting close to 11. Here's what I want you to do. Let's take our 5, wander around, get some air, get some water, check this diagram out, and see if you can tie what Carolyn just said to this diagram. All I did was here was a little dot plot. Little dot plot. You've got all their test scores on the number line. Okay? Wander around. Let's try to quantify when we come back, huh? Good.